with AI, password, and credentials. But before we started, I would like to say that for all of you that have been here, you have a gift. It's 500 tempos for my public inbox. My public inbox is a platform in which you can contact with people that are public profiles, people that are relevant on the internet that probably you cannot contact easily connecting to through social networks, etc. The idea is quite simple. One of the most dangerous things on the internet for the companies is publishing emails, because emails are free, are easy to send malware, phishing, spam, and almost every cyber attack that is happening in a company today is starting through the email. So most of the advanced persistent threats start with email. So years ago, we created this platform, mypublicinbox.com, which is quite simple. You have a public profile, everybody can connect to you, but in order to protect your time and to protect massive messages to your account, it has a cost which is based on tempos. So 500 tempos is more or less around $9, more or less, and allows you to contact people. Everyone decide what is the cost of receiving and responding messages to in this platform, but it's a good way to contact people that want to be contactable, but not being someone that is losing their time answering messages. How many of you have more than 100 messages a day in your inbox? So you are not working, you are answering email messages. How many of you have been almost having an accident with the car deleting messages? How many of you have been in the cinema deleting messages? Doing that? Well, I don't, because I have this as the only channel. If you want to contact me, this is the only channel. If you get my email message for any other reason, you're gonna receive an automatic response that is going to say, okay, this is only for friends and colleagues. If you want to contact me, the only channel is my public inbox. At the same way, you can also contact to all the people that are in the platform. You can have your own public inbox if you want to. And you can also book time for video conference, etc. If you want to have a video conference with me, book in my agenda time for explaining your project and to share information or whatever, you can do it also. But I cannot have 100 meetings a week related to people that want to have a project with me. So as you can imagine, my time is as yours, and I need to protect my time. So because of that, we created my public inbox. You got the tempos. We are going to charge in your account to the email address that you used to book for this event. So right after you open the account, you will receive the tempos in your account. So this said, today we are going to talk about cybersecurity and artificial intelligence. And I'm going to start from the beginning. So it's going to be a journey about artificial intelligence and cybersecurity. And we are going back to the 20th century. How many of you remember 1950s? Yeah, well, 50s, to back in time. So at that time, computer was created. A computer. Probably is very famous that a sentence of IBM saying this is going to be only for 10 or 15 companies worldwide because it's very expensive. It's only for very specific problems. But the idea is that when we created computing science at the beginning, the idea is quite simple. We have three things that we need. We need a user interface, we need data, and we need a logic to solve a problem. That's all. So that's all that we need to create a program or a digital service or a computing program. So in the classic approach to use computers to solve problems, what we have is quite simple. We have data, and with that data, we need to do something. And to do that something is a human, a smart human that needs to decide what. So if you have a problem, you need a smart human that knows how to code the solution and explain to the computer how to solve that problem. So one problem, one human that is smart, knows how to code and find the solution. Once that the human has created the code, we have a system that is able to solve a problem using data. That's simple. Understood? Yeah, quite simple. So problem with this approach is that if you have one problem, you need one program. If you have two problems, you need two programs. If you have 1,000 problems, you need 1,000 programs to solve that problems. If you have 1 million problems, you need 1 million smart people creating 1 million programs to solve them. It's okay? Understood? Quite simple. It's linear. So in order to solve this in the 50s, someone started to think in the crazy idea of solving one single problem, which is, what if instead of solving problems, we solve one problem, which is creating a human brain that is able to solve all the problems? So if we are able to create that human brain, that artificial intelligence, we only need to solve one problem. Quite simple, crazy idea, completely impossible to do at that time. Do you understand it? It's okay? Okay, we are on the same page. Okay, perfect. So the idea is quite simple. Now we have the classic approach. We have blue dots, green dots, that they can be, I don't know, donkeys and dogs. Okay, donkeys and dogs. And the smart human created this program because he knows what is a donkey and what is a dog. Okay, but no one has been learning that way. How many of you have been learning what is a dog? Like, okay, it's an animal, 4 legs, it's more or less this size, but also this side. Could have 3 legs because probably has an accident, is injured. No one. You got one picture or you show one animal and your father, your family said, look, a dog, and your brain learned. That's the idea of machine learning. We need to create algorithms that are able to do that. You see pictures of green dots, blue dots, and your brain create the algorithm. That's the idea of machine learning. If we are able to learn from, okay, X2, Y5 is blue, X6, Y5 is green, X1, Y6 is blue. This is a dog, a donkey, a dog, a dog, a donkey, a donkey. Later, we will be able to say, okay, X5, Y6 is green or blue. Who knows? Well, the idea of solving this at the beginning is quite simple. If we are able to create a mathematical function that is describing the universe in this set of data, we have the knowledge to describe what is that dot in the middle. Problem when you are having that data is that there are a lot of mathematical functions that can describe this universe. We have this model 1, this model 2, this model 3. There are a lot of solutions to do that. All of them are true, but not all of them are accurate. Okay? So we needed to create a lot of research and to create a lot of new technologies since the 50s, in which we were storing data in tapes, in files, to move to a moment in which we were able to manage huge amounts of data. Because if we are able to do exactly the same, but with big data, we are going to be able to describe the universe, to create knowledge, and to be accurate. Problem is that we needed to create the hierarchical databases, the relational databases, the business intelligence, the data warehouse, the SQL, the voice code functions. We needed to do a lot of research. But in 2004, when MapReduce and Google start to create that big data technologies and Facebook started to create Cassandra, we have technology good enough to process, to store and process huge amount of data to be able to run these machine learning algorithms. It's okay? We started in the 50s, a lot of research. We are in 2004, the moment in which big data explodes. At that moment, we start to work with what we call the high performance computing, because we store a lot of data. But when you think about people, you don't need 2 dimensions, you need a lot of dimensions. Let's imagine some customers and you want to define the churn. So what is the probability of this customer to abandon my company? You need a lot of dimensions, all the interactions that customer has with your company, all data that you have related to the social environment in which that customer is right now. Every piece of data that you have from that customer is going to make yourself close to the solution, to discover, to be more accuracy about predicting the churn of that customer. But problem with that is that if you have a lot of data, then you need a lot of computing power. So at that moment, machine learning algorithms based working in huge amount of data were depending on high performance computing. That science was creating big data centers, connecting all the machines together to process all the data and create one algorithm, one machine learning algorithms. Probably you remember the clusters in which you have 2 computers working together, the grid computing in which we have a diverse set of machines working all together, all of them completely different, but with a software layer that are connecting all the pieces in that. And in 2009, one company that was looking for a big amount of computing power for the Black Friday in order to sell books, create the cloud computing. At that moment in which we have cloud computing, we have almost unlimited computing capability and a very, very cheap price compared with using high performance computing. At that moment, we were able to run that machine learning algorithms with huge amount of data at a cost effective. That moment is the beginning of the modern artificial intelligence that we know today. And one of the things that we start to work is in the neural networks. Neural networks are a set of algorithms trying to do the machine learning from data, learn from the data to create the knowledge. But in order to work closer to the human brain, instead of looking for the perfect mathematical function that is trying to describe in any dimensions all the data, which is almost impossible because you always have corner cases, random data, or data that is missing to you because you don't know if, I don't know, one of your customers has a discussion with one guy of your company and you don't know that. It's a piece of data that you don't have to train your algorithm. So we started to work in statistical knowledge, which is exactly what is doing the neural networks algorithms. This is how our brain works. We don't know everything. If you see a tiger eating an animal in the jungle, and later you see another tiger in the jungle, you don't have all the information about this new tiger, but you need to take a decision. So you use statistical information to say, okay, better run. That's what a human brain is doing. So neural network is based on that. And one important thing is that since we started in the 50s to think in this crazy idea of creating machine learning algorithms based on mathematical function, and later we start to work in these neural networks technologies, algorithms, we've been reducing the set of algorithms in which we are working. So the idea is that at the beginning we have 1 million problems that we were solving with 1 million programs. Later, when we start to work in machine learning, we have thousands of algorithms, but that's all. when we start to work with neural networks, we have tens of neural networks algorithms with different variation. And this has made that all the researchers worldwide, from Microsoft, Google, MIT, Columbia University, all the universities are working in the same problem, the same algorithms. And that has generated what today we are suffering, that everything is going very fast. Do you have that feeling that everything is going very fast in artificial intelligence? It's because we've been reducing the scope of the algorithms in which we are working. So that's all. So this said, when you have a reduced number of artificial intelligence algorithms to do machine learning, like neural networks, the only thing that you need, and you have unlimited power, the only thing that you need is data. If you have the data, you have the common algorithms, join both, and you can solve almost any problem. And at that time, we started to work in something that was a barrier a lot of years, which are the cognitive capabilities of the human being. The vision, the knowledge, the language, the hearing, all the cognitive capabilities that a human has have been started to be processed by artificial intelligence thanks to that. So at that moment, we start to work in how machine learning or artificial intelligence algorithm is able to compete with a human in a cognitive capability. And we create something that we call the human parity. Human parity is a benchmark. If you have with with artificial intelligence algorithm, with a cognitive service algorithm, you have less error than the average human in one capability, then you reach the human parity in that capability. And it's amazing because all the researchers were looking for that. I want to be the first researcher achieving the human parity in recognizing people on pictures. I want to be the first researcher to recognize the kinetic in pictures, discovering that it's a picture, but there is a cap that is going to fall down if we hit play. To recognize the 3D of a picture. How many of you remember in Twitter the mannequin challenge, in which you needed to stay in the office completely still, doing silly things, and someone was moving around you with a camera? That was because we needed data to train the cognitive service to, given a picture, recognize the 3D. And how many of you remember the 10-year challenge, in which you needed to publish a picture of you now and 10 years before? Thanks to you, if you were cooperating in that challenge, thanks to you, we have the last Indiana Jones movie perfectly, because that was needed to train the algorithms to de-aging or aging people through from a picture. So we started with that race, and today almost every single cognitive capability of human being has been reached. So this is an example in 2016. This is a picture that the wonderful Kevin Mitnick that passed away the year before. We were in Chile, and we took that picture. He was using my beanie, I was using his glasses, and we tried to see if the cognitive service for celebrity recognition was able to recognize us. And as you can see, okay, it said Kevin Mitnick is on the right, and my confidence is 99%. On the left is Chema Alonso, and my confidence is 89%, because there weren't many pictures of me without the beanie on the internet at that time. So it was in 2016. And what the researchers did was taking picture from people from the internet, 1,000 people, 1,000 pictures per person. So it was something that I needed to reconsider in my time, the number of pictures that I published. And as you can see, it reached the human parity in recognizing people. I'm telling you all this story because we have also hallucination. This is another cognitive services that Microsoft Research published that was reaching the human parity. And as you can see, it says that me and George Clooney are the same person, which is something that happened to me all the time. People is saying, okay, George. Well, that is cognitive service. At that moment in the artificial intelligence story, we were trying to be exactly like humans. So we are reaching the same capability in cognitive capabilities than human. But in 2014, we crossed the line. And the idea is that at that moment in time, we wanted to be more than human beings. So at that moment is, okay, I know how to play chess like humans because I was able to train my deep learning algorithm with all the chess matches that humans have been playing along the history. I have all the data. So I trained my neural network with all that data. And later I have a wonderful artificial intelligence to play chess, which is very powerful. Probably you remember Deep Blue from IBM. It was that, a deep learning algorithm based on neural network that was trained with all the data from human history chess matches. So at that moment, we have a cognitive service, but our researchers in 2014, July 2014, this paper was published. It's a Canadian researcher, and it was about generative adversarial network. And the idea is that we have two artificial intelligence. One is the discriminator, and the other one is the generator. So this artificial intelligence is already trained, had been trained with all data for doing a task. In this example, we are training this cognitive service to recognize Chem Alonso. So I trained this cognitive service with pictures from Chem Alonso, and it has the human parity. So it will be able, the discriminator will be able to recognize Chem Alonso in all the pictures. So if I give a picture to the discriminator, it is going to say yes or not. It is Chem Alonso or it is not. That's simple. So the generator only knows how to draw. So we give to it a blank page and colors. And we said, paint Chem Alonso. So it generates dots with different colors and send it to the discriminator. And the discriminator is going to say, my confidence in this draw being Chem Alonso is 0.00000 is not Chem Alonso. Okay. But as computing power is unlimited because of the cloud computing, it is going to modify the draw and it's going to try it again and again and again and again. And this is something that you need to understand carefully. The generator is always going to beat the discriminator. So at that moment, this artificial intelligence is going to be able to draw Chem Alonso. And it is what is happening. Reality is that now we are thinking about pictures, but let's change a little the subject of this structure. Let's suppose that we train this with all the chess matches, as we did in Deep Blue. This is Deep Blue. Do you remember Deep Blue playing against Karpov, Kasparov, and getting even with them? So this is Deep Blue. And now we take this another artificial intelligence. And that intelligence, we say, okay, the tower goes always red and to the left, or vertical or horizontal. We have the king that is moving one by one. We have the pawn that is moving two at the beginning, later one by one. So we explain what are the rules to playing chess. And we said to the generator, okay, beat the discriminator. So in the end, the generator is going to play better than all human beings, which means that it's completely impossible to beat this guy, this artificial intelligence. Probably you remember Alpha Chess, AlphaGo, Alpha whatever. So today is completely impossible to win one artificial intelligence that had been trained with this technique to any game. Almost, it's impossible. AlphaGo, Alpha Chess, probably you read the news. So all the human championship has been defeated by this technology. But we are using this technique also for creating codes, to creating almost everything. This is the core of the GenAI that today we are discussing, which is the generative adversarial networks. So the idea of this is, okay, we have an artificial intelligence that is able to create things. It's able to create things that doesn't exist. So we can create things that are completely new. And problem is that if we start from scratch, from a blank page, or if we start just teaching how to move pieces on a chess game, it is going to take long. So since that moment, what the researchers have been working on is how to make sure that the discriminator is going to be the generator is going to be able to beat the discriminator in a shorter term. So faster in 1 second. Today, we are used to that. You write a prompt in ChatGPT and you have the answer in seconds. ChatGPT is beating the discriminator that is configured by your prompt in seconds. But it started that year. So what people started to do, okay, let's simplify the problem. We have a video of Barack Obama, and I want to create a deep fake. I want to create a fake video of Barack Obama saying things that he never told. So what is going to do the generator is, instead of working in the whole picture, it's going to work in this example only with the lip sync technologies. At that moment, what it's doing, the generator is working only in synchronize the movement of the lips with the words that we want to make that video says. So that's quite simple. And it's very difficult to discover that because someone can manipulate it very easily. This other example is exactly the same, but instead of creating the whole picture, we are going to work only here. And the idea is wonderful and very simple. The discriminator is configured to recognize him, and the generator is taking a picture of him, blur the picture, putting the picture like you were cutting and using tape on top of that, which is very rude. You can see it easily. And then the generator is going to refine to the noise the image pixel by pixel. And it's going to do it. It's going to make able to do it very, very, very quickly. So this is lip sync and face swapping, which is something that Cybercriminals have been using a lot. This is a sample that we did in 2019. The idea is different here. What we did at that time is train an artificial intelligence, a GAN, a generative adversarial network, with a video of myself. And later we have the generator is working in the landscape, just looking for the expression of the face, etc. So this is one of my colleagues. He is in front of the camera. The camera is using artificial vision to recognize the gestures, how the mouth is, etc. And the other one is recreating myself in real time, which is, at that time, it was rocket science. Today is quite simple. Everybody can do it that. But this is very dangerous. At that time, when we were able to do it, we were concerned about everything that will come after. Because as you can imagine, cybercriminals really bad people are using this kind of technologies today. So this is an example, something that we call the CEO attack, in which you impersonate one person through a video conference and you ask to do things in the company. And today is quite common. So we are able to create some images. We are able to create that quickly. And in 2016, we have another breakthrough in that techniques, in this technique, which are the diffusion algorithms. And it's wonderful because it's injecting a failure in how technology works. And that failure is what makes the human beings to be creative. So the idea is that if I show you a picture of, I don't know, Van Gogh painting, I show you the picture of Van Gogh painting. You are looking to the painting, you are putting attention to the painting, a lot of focus to the painting, and I take it away. And later I say, okay, draw the painting. You are unable to do that. You can say, well, I don't have the skills to draw the painting. Okay, let's suppose that I create 50 different variation of that image, small variation. You are not able to discover which is the original one. At least you are a real expert on Van Gogh. This is because our human brain is not created to store complete picture, complete data of everything that we feel, not anything that we see, not anything that we listen. So how many times have you been discussing with someone that says, no, it wasn't that way, he said this thing? Probably he's right, because your brain is not storing the full copy. It's storing some pieces of what happened, information enough to take a smart decision to survive, to say, okay, a tiger, I need to run. That's what your brain is storing, not the full copy of the data that you feel, that you experience, not at all. So if your partner said at any time it wasn't that way, think twice. Your brain can be storing not the right information. So what the researcher did at that time in 2016 was this small piece of wonderful technology. So they were taking one artificial intelligence with a cognitive service to describe pictures, for instance, describe pictures. So we take 1 million pictures and I go one by one using a cognitive service, describing what is in the picture. It's a picture of Times Square at night. There is a cap in the middle and a woman with a red dress and a man with a suit or whatever is in the picture. And then, if it was a puzzle in which you create the puzzle. Have you ever doing puzzles? No. Solving puzzles with pieces. Let's suppose that the picture is a puzzle. So I finish the puzzle, put it in the box, close the box, then tape on a piece of paper with the description what is about the picture, okay? And then you take the box and shake it. The puzzle is going to be destroyed, completely destroyed. But inside the box, there are the pieces that you need to create what is described on top of the box. Is that right? Yeah. Well, let's suppose that you do that 1 million times with all the puzzles that you have, 1 million pictures, 1 million boxes. Later, you put all those in your database. And then someone goes to the generative adversarial network and you say, okay, I want you to draw a blue cat on a yellow skate. That is the configuration for the discriminator. So the generator doesn't know how to create that picture, but goes to the database, read the description, and look for puzzles, destroyed puzzle, defuzzed puzzles that are close to it. So 6, 8, 10 boxes, and then mix all the pieces, all the pieces, and later, using that amount of pieces, start to try to beat the discriminator. What is going to happen? Well, we reduce the problem from 16 million different colors per pixel to a small amount of pixels coming from the boxes. So the generator is going to beat the discriminator so quickly, so quickly. So I give you the image, you describe the picture, it matches with the configuration that I have, yes or not. And the moment that it matches, it close to the description of the picture that I need to create, is wonderful, because the discriminator is going to give you the answer, and at the same time is going to describe the picture, put it in a box, randomly store all the data in the database. So it's learning by using. Every time that you are using one of these diffusion algorithms to create images, you are teaching the artificial intelligence to be smarter. So today, it's quite simple to train one of those algorithms, diffusion algorithms. These are pictures that I train with 20 pictures. In my public inbox, we add that algorithms. You upload 20 pictures of yourself. This is an example, 20 pictures of myself. You train the algorithm, and you can ask for million different pictures of yourself. Cool, green, photorealistic, futuristic, whatever you want. And the way it works is that, which is wonderful, because same algorithms, GenAI, Midjourney, 2022, this is the prompt, 2023, the same prompt. Look about the quality. It's amazing. But have they recognize the difference between reality or picture in 2 years is going to be completely impossible. Completely impossible. Not only in picture, but also in videos. And with that technology that is able to create something that doesn't exist, we have a lot of use cases that people are using. This is one of the use cases is photo expansion and recreate. The idea is that you have a piece of the picture, and with artificial intelligence, you use this as a prompt to generate the rest of the picture. For instance, Photoshop, which is a common tool for designers, has that as a part of the service. You have a picture and say, okay, I want bigger. And it's trying to recreate new pieces of the picture. This is an example, and as you can see, you can create something new. But it can be used for a lot of things that are not so good. One of them is deep nudes, in which people are taking pictures of people and making them nude and publishing on the internet. Today, as you know, in the States, this is something that is forbidden for law. You cannot do that, even if something that is fake, because even saying that it's fake is forbidden for law. And in the porn website, they are creating a new line of videos using public profile pictures to create whatever video that you want. So this is an example. And this is another example of photo expansion and recreate that I really love. You know that in WhatsApp, there is the view once pictures. You send a picture, view once. How many of you have been sent picture of view once? You know that any other can do a picture. So it's a false feeling of secure. I really hate that kind of features in technology, because you feel secure thinking that it's view once, but anyone can do a picture. It doesn't make sense. But it has a leak, which is this. Can you see it? The thumbnail is a thumbnail of the picture. You cannot capture the picture, but you can capture the thumbnail. And I did this to my daughter, explaining how technology works. So you have that thumbnail is this size in real. This is the number of pixels it has. And using GenAI, you can extract from this. You can see, you can get information to this. It's creating something, but it's creating something from the thumbnail, and it's drawing very, very, very well. So that idea of recreating things can be wonderful for a lot of use case that can be used in a hack. This is another example from this summertime. Is Deep Tempest. Tempest Technologies allows to anyone to reconstruct the signal on a computer or what is doing in one screen just because of the waves that you capture from the air. So this is an example in which the researchers were having a computer connected through an HDMI cable. They were with an antenna and software-defined radio technology grabbing the movement of the waves on the air, and later using a neural network able to reconstruct what is on the screen, looking for letters, etc. So it's for spying what you are doing in the computer. It's wonderful, the use. Of course, if you understand how GenAI works for playing chess, for making draws, for making videos, etc., for making audios, it's exactly the same. In 2023, we started to see all this GenAI technology to manage voice. Today is wonderful. You can do almost whatever you want. You can replace singer in songs. You can say, okay, I want Freddie Mercury singing Bad Bunny songs. If you do that, you're gonna be in hell for sure. But you can do it. So you can do it. And in 2023, we started to see how cloning voice became very, very easy to do. This is a website. It's called 11 Labs. We've been using that platform since the beginning. We were using a lot of them. Even Microsoft has the Azure Cognitive Services in which you can do a duplicate of your voice. At that time, in Spanish, it took more than 2 hours reading messages, and with the mic, you needed to be logged in Azure with your Microsoft account, recording with your voice the message. 2 or 3 hours, the first time that I did that in Spanish. Right now, with 11 Labs, you can do it with not 10 files, just with once today, with one file. And the only protection that they have to make sure that they are not creating a clone voice of someone that they shouldn't be is a checkbox that said, I'm allowed to clone this voice, which is something that is stopping cybercriminals to do all the time. The famous checkbox that I'm good guy. So cloning this, you can do almost everything. And of course, biometry is out of the scope. Today it's very complicated to have a secure voice biometric system. In 2022, when this started in the UK, all the banks were using voice biometry of second factor authentication for customers, and they needed to replace that globally because it's convenience, but it's not a real second factor authentication. We saw a lot of use cases in which cybercriminals were cloning the voice of the CEO. We have 2 use cases. One, this started in the Wall Street in 2019. It wasn't very big. It's only 220. But there is another one in 2020, about $35 million, in which they use a 3-step attacks. First one, they clone the voice of the CEO and call the bank saying, hey, I'm in the middle of an M&A operation. I want to buy a company in Hong Kong. I'm going to send one lawyer to sign all the documents, so please do it today. At the same time, in the bank, they received the data of the lawyer because they were using a stolen account, stolen email account, and they were receiving, okay, the name, the ID, the passport number, everything related to the lawyer. And in the next 10 minutes, one guy entered the office, signed the documents, and they wired $35 million to Hong Kong. That's it. And this is one example that we did for a hacking conference, we called Chucky Alonso. It's quite funny. The idea is that, okay, we were talking about advanced persistent toys. The idea is that you have a toy, and inside the toy you can put a mic and a speaker. You have a mic and a speaker. You can clone voices, and you can use that clone voices at home. So we did that. We put a Raspberry Pi inside Chucky, and what Chucky was doing is quite simple. I'm not going to do the demo. It's in Spanish, but the idea is that it listens to you when you are speaking at home. Listen to you. It collect all data and upload it to 11 labs. Clone your voice, and once that clone your voice, then you can remotely say, okay, I want you to talk to Google or to Alexa and ask for the list of items in the agenda, or you can add this to the agenda, etc. It's nice because I used to make pranks to my friends when I was at their houses. I used to go and say, Alexa, add this crappy thing to your list. It's quite nice. You can buy a lot of things. And it's amazing when they receive the packages. If you see an Alexa at home of your friend, you can ask for a list of crappy things. But probably most of people don't know, but Alexa and Google Home are storing every piece of voice that they listen when you are asking for something. So we said, okay, we cannot use our voice. We need to clone the voice. And because of that, we did this with Google Home and with Alexa, etc. So today, your voice is at risk. Of course, you can imagine WhatsApp audio message. Your voice is enough to clone your voice. So we need to work in the scenario of everyone is losing the control of their voice. So that's the situation. So if we move forward, we go to the next phase, which are the digital humans. This is an example of MetaHuman. MetaHuman is a software that had been created for gaming companies. This is a digital human that has been created in 30 seconds with a smartphone, just one smartphone, around 30 seconds, and it clones that person. As you can see, you can manage in real time, change everything, and have a digital human. Today, there are a lot of companies creating digital human as an evolution for bots. At the beginning, we have bots, chatbots. Right now, we are looking for digital humans, and there are a lot of investment in that area. Of course, cybercriminals can also use digital humans. This is MetaHuman 2023. This December, we are going to have MetaHuman 2024. We don't know yet what are the improvements, but if you go to the NVIDIA website, you will see the new digital humans they are creating, which is amazing. And this is a nice e-commerce. You can go and buy a digital human. This is 3D scan, and the business is quite simple. You go, you sell your body, they scan you in HK, and they sell you. That's it. And you can go there and buy digital human. This is one of the digital humans. Look, the quality of the developer is managing the digital human there, but you can see the quality of the skin, the eyebrows, everything. 3dscan.com, you buy your digital human and you use it as you want. So this idea of cybercriminals impersonating real people on the internet through video conference is something that worries us a lot. This is another example. April this year, Microsoft research team was publishing this. In this example, we have an artificial intelligence model, a Gen AI model that is creating someone that doesn't exist. This person doesn't exist, and is working that way. You type the message. The message is created in voice with a cloud voice, an artificial intelligence create voice. the image is not is of someone that doesn't exist, and at the same time is going to do lip syncing, and is going to generate micro gestures to make more human that share. This is RAISA 1. So you cannot listen, but as you can see, he's speaking and he's talking about motivation, and he's moving every single piece of the face to make that more realistic. So in order to understand how dangerous this could be, in 2012 and 2022, there was a research in a university, and the idea was, let's see if people are able to recognize artificial intelligence created human, a synthetic human or not. And they were doing a test which is, I show you picture of real humans and synthetic human, digital humans, and you need to say yes or not, real or fake, real or fake. If we were doing that test with a drunk monkey, with a bandage on the eyes, just pushing buttons and receiving bananas, we were having 50% of probability, which is like flipping a coin. Okay, we as human, we were able to get 48%, so less than the drunk monkey. So managing the expectation with reinforced learning, saying every time that one human was saying real or fake, the system was explaining, okay, you were right or you were wrong, just to make you learn from the previous answer that you did. We were able to achieve 52%. So there's a small piece of hope for humanity. But one of the most wonderful part of this research is that they were asking for another cognitive capability of the human beings, which is the prejudge. So you saw someone with a beanie hat, long hair, and you say, why this guy is working for Telefonica? Probably you don't know a lot of things about me, but you are creating some thoughts related to me, which is good. This is what makes human beings to survive. You see a tiger, you run. You are not asking probably this. You are not thinking, well, probably this tiger is good. This could be vegetarian. Not. You see a tiger, you run. You prejudge. They were asking for trust. What is the level of trust that picture is generating in you? And as you can see, synthetic people are generating more trust than real humans. And the explanation is quite simple, The new generations of people have been trained years and years to deal with digital humans. And the reason, because they were trained to do that, is because in the social networks in which people were publishing their pictures, they realized that the engagement was reducing along the time, and people that were very famous on Instagram, they were reducing the number of pictures that they were publishing. They were people on the social network were thinking, what is the reason? This guy is very famous, millions of followers. Why is he stopping of publishing picture? And the reason was very simple. Human beings tend to be older every day, and they compare themselves with the pictures from the past, and they said, I don't look very well in this picture. So smart people on the social network found a solution, which was the beauty filters. So a new whole generation of people had been in love with their idols that are digital humans, because all of them are using beauty filters. And because of them, the new generation trusts on the digital human more than the real human. Of course, as you can imagine, these technologies are in use by cybercriminals to do bad things. This is an example about a European politician. It was before the Ukrainian war, and he was invited to have a meeting, a video conference with this guy. This guy was supposed to be a political in Russia against Vladimir Putin, and they were having this video conference. And after this discussion, everything that he was saying was published on the public television in Russia about what supposedly the Europeans were thinking about Russians. And this supposed to be politician said, I never had that meeting because it wasn't him. It was an actor using deepfake technologies to pretend to be that, and they were using that technologies as an APT. Of course, they are using that to have people inside the companies. This is a very common technique today to hack companies, especially bank institutions, industrial companies, etc. What they are looking is for a job opportunity to work remotely as an IT guy or a technician, which is wonderful because you have a lot of access to the IT system. You have username, password, you are connected to the internal network. You can do a lot of things, crappy things, and they are putting super smart people applying for IT support jobs, and they are getting the position. This is an example. This was an alert in 2022. This is an example of the company that was having Kevin Mitnick as a chief hacker executive years ago. And it was nice. It's a guy that was pretending to be an IT people. And of course, he was overqualified for the role. He paused all the interviews, and it was the alert that make the people think that, okay, probably this is a deepfake. So today it's quite simple to do a deepfake, and there are a lot of scammers that are using this technology. This is Deep Light, is free. You can use it for free in your cameras. This is an example about how it works. And what the scammers are doing today is they are looking for victims in the social pages of the celebrities, looking for people commenting on them, oh, I really love you, I really love your last movie, whatever. And they are later selecting the victims and contacting to them directly, saying, okay, thank you for your comment. This is my personal account. I didn't want to share that with the whole people, but I really get thrilled about your message and blah, 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 blah. They get trust. At some point, they have video conference pretending to be the celebrity, and later it's like getting money, getting money, getting money, getting money. In Spain, we have a lot of cases of this. In the States, a lot of cases. And they are saying, okay, I just helped George Clooney to take a flight. So that's the idea. So this is something that is happening worldwide. And what we started to work years ago in 2018, when this was started to be a big problem in the cybersecurity industry, we started to work like Blade Runners. Have you seen the Blade Runner movie, the original one? Who have not seen the movie? All of you? No, you don't. Please abandon the room. So in that movie, it's quite interesting because this guy, Harrison Ford, is the Blade Runner, and Blade Runners need to discover the replicants. And the replicants are not digital human because they are physical, but they are humans that had been created in a company, in an industry, are artificial humans using biotechnology to create the humans. And they are very strong, they are very smart, they are very fast, and they have they have forbidden to be on Earth. So the Blade Runner needs to discover. And the only way to discover to the replicant is to look for human weaknesses like empathy, generosity, love, that kind of emotions that make humans. And they were using this piece of technology, which is fake, is the boy cam test, in which they are analyzing the pupil, trying to to discover uncontrolled emotions in situation. And if they don't have that uncontrolled emotion, then it's a replicant and they need to kill him. So they are asking things like, okay, you go through the desert and you see a turtle upside down, what do? So you receive, you generate empathy for the turtle and you try to put it in the right way. But if you are a replicant, you don't understand the question. What is the question? What is the question? So what we are doing today in technology is more or less the same. Let's try to discover human things that are not working in that video conference, in that picture, in that digital human. Let's try to find that small or non-human pieces that we can discover from the video conference. So there have been a lot of research. This is 2019. This is quite simple. It's a machine learning technology. You have a lot of videos with deepfake technologies, a lot of videos that are not deepfakes, and you try to create that machine learning technology algorithm that describe the deepfakes and non-deepfakes. And we are looking in that algorithms, we are looking for what we call face warping artifacts, which are how the artificial intelligence is drawing the deepfake when it's creating the Gen AI. As you can imagine, when the generator is trying to be the discriminator, is using an algorithm and is working more or less in the same way to generate the pixel of the picture. So this is one of the examples. The other one is, okay, we have an artificial intelligence that is generating photograms of one person, but is thinking on beating the discriminator photogram by photogram. So probably it's not taking care of having the eyes gazing exactly the same position. So you can discover a deepfake in many cases because they cross the eye, the eyesight. Yeah, it's very common. So this is something that the new technologies are taking a lot of care right now, because if you move the eyes, then everybody is going to discover that it's fake. That is fake. This is another that I really love, which is the eye blinking. The idea is that you have a person and you have data about how many blinks, what is the speed of the blinking, what is the time between blinks, what is the average space between blinks, etc. And we are using this to create a blinking printing for your colleagues in the company. So you have the blinking printing pattern of your colleague. It's not a joke. We are using that internally in our team. So if someone pretends to be one of your colleagues, the blinking printing is going to say, hey, it's not blinking the same way yesterday was blinking. That's the idea. The same with gray histograms. Histograms is quite interesting. This is another machine learning algorithms that is looking for the gray histograms, because the artificial intelligence is generating the fake images, trying to fake human. So it's very soft. And in the gray histograms, you don't see big peaks. So when the image in gray histograms is very soft, it's probably a deepfake. This is another research that was created. This is another wonderful, is looking for the symmetry, the difference between the highlights in one eye globe and the other one. If the highlights are not exactly the same or close enough to be the same, then probably it's a deepfake. Why? Because I'm here on this stage and I have that light, that light, that light. My two eyes have exactly the same number of lights. So they should have more or less the same highlights in the iris. If not, then it's a deepfake. This is something that we are looking also in the algorithms. And this is the head pose algorithm. Another research that is looking for deformation for stretches of the bones. So the idea is that if this is a real human, there is a skull and there are bones behind the skin. So is what the algorithm is doing is generating a 3D mask of your head, like with triangles, and looking for a vertical point. And when you move the head, if one of the triangles stretches, then it's a deepfake. So it looks like sci-fi, but it's not. It's real technology today. And this is another example, which is based on heartbeat. The idea is when you have a small watch, you can have a heartbeat because of the reflection of your skin. The difference in the reflection belongs to the heartbeat of your blood. So you, in a video conference, you can look for differences in colors in the forehead, close to the mouth and the neck. And if there is enough, and when you have that, you can see the heartbeat. So you can do in real time a heartbeat of someone that you are having a video conference. And of course, you can have the heartbeat printing of that person. This is something that we are putting in place. We started in 2019. This is an example. This is one of my colleagues. And right now, we are going to use deepfake technology in a video conference. So as you can see, we create a deepfake that is on Teams and is changing the face a little, just enough to not be recognized, with glasses here, or being Arnold Schwarzenegger, which is wonderful, and you look sexy on the video. What we are doing with this technology is in real time, we are capturing frames of the video conference, and we are analyzing all of them in the backend to later have an analysis of all those algorithms that I was explaining before about the heartbeat, the blinking printing, the head pose, etc., just to recognize if that guy is using a deepfake. When you have 1,000 employees, the probability of having one of your employees targeted by one attacker using deepfakes is huge, and you can have that. So this is for real-time video conference. We have also that algorithms for forensics. This is quite relevant, especially for newspapers, for journalists, for justice, in which a video is used as a proof or to support one fake news. What we are having is, okay, you upload the video, we pass all the algorithms and try to discover what the algorithm says, and you have, okay, this is very likely, it's very unlikely, what is the probability of being a deepfake? We have a free version on the internet that you can test, which is that URL, verify.to.com, in which you can upload a video and test it. Not all the algorithms are in the free version because it's expensive to run the algorithm, but you can test it. And another example, which is very relevant, in which cybercriminals are using this kind of technologies, is for the digital onboarding on e-commerce, in which the know your customer requirements are in place. They need to upload a video, a picture of the ID, etc., and they are using that kind of technology. So we analyze using APIs. You send the video, you send the picture, and we say, okay, the probability about being a deepfake is big. Okay. So until this point, we've been talking about everything but LLMs, which is the next step. In 2017, this paper was published. It was published by the Google research team, and is the beginning of the large language models. And the idea is quite simple. They were looking for a similar structure about the GenAI to the GenAI technologies, but applied to text. And they were looking for a better translator, which is very easy. I mean, we have tons of books written in English and tons of those books translated to Spanish. Let's teach a deep learning algorithm to translate. We have the data, we have the structures, we have the algorithms, so let's make it possible. But they realize that the same expression was translated completely different and in different books, and it wasn't working very well for a translator, in which someone is just writing a sentence. Because in a book, that sentence have a big context, which are 300 pages. So for the translator, the human translator, there are a lot of meaning in that expression at that moment in the book. But for the artificial intelligence, it doesn't. It's only a sentence. I need to translate this. So they created the transformer, which is a structure in which they are analyzing the sentences, describing what by tokens what is every word. So this is a name, this is a pronoun, this is a verb, this is an adjective, this is an adverb, etc. And later, when they were doing the translation, the structure is putting the attention in the most relevant words of that sentence. That probably is the verb, or probably in some specific case is the noun, but mostly the verb. And then they change the structure like a transformer. Do you remember Transformer, Decepticons, and Transformer? They are moving the structure, connecting, using the verb as the attention layer, and from that point trying to get the best translation. Something similar to that. It's quite wonderful, the structure. So they were able to create a Gen AI technology, because we have the discriminator that had been configured with the original expression, and they need to translate. They need to be the translator. Creating that, they were opening the Pandora box. Because if you can ask for a translation, can ask also not for a translation, but for a discussion. What is the best answer to this prompt? Not what is the best translation for this prompt. What is the best answer for this prompt? And large language model technologies were created. The wonderful part of this is that they created that and they published in a public paper. So everybody around the world was able to learn that kind of technologies. And if you remember at the beginning of this talk, when I was talking about how problem has been reduced in scope, when we are in the LLMs, we have all the scientific community working in one single algorithm, which is the large language multimodal technologies, which are ChatGPT, Claude, Gemini, Llama, and all that models. Because of that, everything goes so fast. So what are doing the cybercriminals with this? Well, a lot of things. First of all, using LLMs as a copilot to create malware, to create exploits, etc. And malware and tools to look for vulnerabilities in real time. Today, this is a paper from this year. They were able to have website looking for the best vulnerability just with an LLM. It's like having an agent with only target, hack that website, and it's going to do everything that pen tester used to be doing, which is footprinting, discover, test for different vulnerabilities, analyze the technologies, do the fingerprinting, the footprinting, everything related to that. And of course, once that the LLM is able to discover the vulnerability, is able to perform a SQL injection, a cross-site scripting, a cross-site request forgery vulnerability exploit, whatever. Of course, there is something that is wonderful, which is the CAPTCHA, that is supposed to detect non-human technologies. And today it's easier to hack the CAPTCHA with artificial intelligence than being human. So this is an example about HBO Max CAPTCHA. You need to configure the hand in the direction of the object. And it's quite nice because if it's not, you click in next and it goes to the second one. And if not, go to next. And the only thing that you need to do is ask to GPT, okay, is the both picture in the same direction? I say yes or no. So for a cyber criminal that that is creating an automation for this attack, this is not a barrier. I love to do that. I've been doing this with more than 100 different CAPTCHA, and it's amazing how right now GPT-4 is not able to pass this CAPTCHA, but 4.0 is able to do that. But right now 4.1 is able to do that. So it's amazing. And of course, one of the things that you can do is to write things on the internet. So you can write emails, you can write blog posts, you can write messages in Telegram chats, you can do a lot of things. And it's amazing because you can do it with a political intention. So you can ask ChatGPT to create 10 tweets to attack one journalist, for instance. And later you can move that picture through bots in Twitter easily. I did that on TV, in one TV program in Spain. I configure 100 bots of Twitter, and I went to, and we create a tool that was asking for 100 different tweets saying that one journalist was very bad person in one interview with a woman. That interview never existed. Even the name was invented, completely invented. And in real time, I clicked the button. The 100 messages were created by ChatGPT. The 100 bots were publishing the message. It was trending topic in Spain, and everybody was asking, who did that? Why did that? And complaining about the journalist, and the journalist didn't do anything. So this is an example about people using ChatGPT to generate political thoughts in Telegram messages that are real, that have been published by OpenAI in one of the campaigns that had been stopped in one of the conflicts in the world. And this is an example that we did for a blog. This is quite simple. We generate a GenAI blog in which we were collecting blog posts for different sources. We create fake journalists using fake digital humans that doesn't exist. We were downloading the text and asking ChatGPT to rewrite the blog post and publish a new article. And we were creating a blog post that was index, refer, etc. in all the sites. But we wanted to go a little further, so we create a system that was able to take one press release from the government, and you were able to decide, okay, I want this press release rewrite with against the government, favor to the government, and you can select the level of aggressiveness. So you want to be very, very opposite to that, or you want to be very, very a favor. So we were creating left and right news in real time using GenAI, which is something that a lot of people are doing today in election time. So this was an example. And the last part related to artificial intelligence that are relevant to me are, this is a OWASP Open Web Application Security Project is focusing looking for the most dangerous weaknesses or vulnerabilities in technologies. In the case of GenAI products and services, GenAI technologies, they created a list of 10. Today, I didn't talk about all of them, about prone injection, jailbreak, all of those, but there are two that are very relevant. One is the excessive agency, which means that if you are using GenAI technologies today, you cannot trust 100% on them. Because of that, most of the people are talking about copilot or cooperation between human and GenAI, because you cannot describe what a GenAI have been learning. So explicability, or knowing what a GenAI have learned after being trained, is very complex. It's something in which all the researchers are working today. So this is a nice example from 2000, this is in the States. We have the same in Europe. This is a political declaration on responsible military use of artificial intelligence. And I love this, in which says, basically, okay, let's take care and not let the artificial intelligence technology to launch nuclear weapons, which is amazing. We have the same in Europe. This is February 2023, and September 2023. We have an event in a summit in Europe, and we create a similar message. And one of the things that I really love is that if you understand how GenAI works, probably you understand that the only purpose of the outcome of every GenAI technology is to beat the discriminator. That's it. So it doesn't need to be true. It does need to be enough to beat the discriminator. That's it. Okay? That's it. So when you ask about true facts, you have a big problem. Because of that, we are creating a special rack architecture with grounding techniques, a lot of things to make sure that we are not dealing with this, with hallucination. And this is one that I really love, because if you ask at the beginning to Gemini, in this case Bart, when they were having Bart, and you were asking for me, for Chema Alonso, you were saying, okay, do you know Chema Alonso? Yeah, he's famous Spanish hacker, blah, 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 blah. And you ask, it says that I was born in 1917, which is not true, but good enough to be the discriminator. It said that I started like a black hat, which is not true. I'm always working in the bright side of the technology. But it says that I've been writing a lot of books that I never wrote. And this piece of technology is quite amazing, because it says Alonso began his career as a black hacker in the 19s, which is not true. When he was working as a pirate in 2001, he was arrested by the authorities and he was put in jail. And after 2 years in prison, he transformed himself in a good guy. It's not true at all. I never went to prison and always a good guy, but that can happen with GenAI technology. So you need to take care of that if you are using it. So the last part of this talk is about thinking that the cybercriminals could be inside your company. They can use a lot of tools today, GenAI to hack your website, GenAI to bypass your security controls, etc. And of course, they can have credentials for your company, because they are working as a rogue employee, tokens, they have tokens or session cookies or whatever. And we need to recreate the security protection in company, not thinking only in the identity management, how to manage identities of my customers or my employees, but creating authorization controls for all the functions, all the system, etc. So this is one technology that we use, which is a platform for authorization control. So we have the employees, we have the authorization layer. So when the users, the employees are going to use or manage anything related to the company, they are going to create a backup, they are going to delete a backup, they are going to create a user, they are going to delete a user, etc. We have a layer, a security layer based on latches, in which you can control if the mechanism is open or not for that usage at that moment. And this is wonderful, because if one attacker gets access to your password or get access to your credential and it's inside the company, the attacker is not going to be able to do anything if you maintain the authorization control mechanism, if you control the latches. This is something that we are putting in the company and allows to secure all the companies beyond the username, the password, or the employee. So this is the next stage on creating a secure part of a secure platform in the company in order to protect everything. And that's all. I'm in time? Amazingly, I'm in time. 5 more minutes. So if you want to make any question, I'm open to answer all of them. I don't know if on the internet anyone wants to do a question or here. So go ahead. Yeah. Yeah, well, I'm going to repeat the question for people on the internet. So the question is how you protect your identity after publishing your voice in videos, your pictures on the internet, etc. Uh, well, the answer is that we don't have the answer. We don't have the answer today, and it's very complicated, but it's a reality. We were suffering that in the past with the Photoshop pictures. In the past, someone can use your image and create a Photoshop picture of you and create a campaign against you using your image, and you cannot control that. And it happened in the past. It happened many times in the past. But problem is that with Gen AI is quite simple and quite perfect, so perfect today that we need to rethink how to manage that. First thing that all the countries are doing is creating laws about that. You cannot use the image of a third party to on your systems with artificial intelligence, and because it's forbidden. So if you go to, for instance, Bing, which is using Copilot to create images, and you ask for a picture of Chema Alonso or Elon Musk or Donald Trump, is forbidden. It's not going to be allowed you to ask for that kind of pictures. But we don't have all the answers because someone can train the algorithm in a separate machine using a cloud tenant and can create videos, photos, everything related to you. I was showing at the beginning that porn website that allows you to select, okay, I want to watch this video with this actress or with this actor. And it's like a pandemic right now, tons of websites doing that. So we need to work on that. First, regulation and law, which is something, but we don't have technical answers to solve that problem today. That's the reality. Only 2 or 3 professionals. Yeah. 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 Well, the number of profession in danger with this kind of technologies is huge. You were thinking about translator, voiceover, etc., architects, or to create audiobooks. Right now, you can use the voice of the writer. So you clone the voice of the writer, you give it to the whole book to the algorithm, and companies, publishing companies are starting to do that. But in Hollywood, there we have a big movement of people on a strike because right now actors are not using their voice because voice has rights, author rights. So the companies are forcing them to sign. Okay, you are not going to use the voice. The lips also are synchronized with technology, with lip syncing technology. So the translation in French or in Japanese is perfectly accompanied with the lip syncing. Also, they are using digital humans for atrecho people, secondaries, etc., because it's cheaper. So you can put many digital humans on behind. So we are in the middle of industrial revolution right now, and it's going to be worse because today you are seeing the worst artificial intelligence that you are going to see in your life, because tomorrow is going to be better, the day after is going to be better, the month after is going to be better. So we need to rethink a lot of the social contract with people, companies, money, individuals, etc. But one of the things that we believe that are going to be very relevant is or are the humanities and what make people people. So, for instance, emotional, uh, philosophy, that kind of disciplines are starting to become very relevant. We need to think about what we want to do in the companies or not with the technology, what make feel good to our customers or not. We started to rethink everything in the companies because of this technology, and we don't know. We don't see all the possible branches of the future, but we believe that we need to put the human in the center. If not, this is going to be a dystopian world. No, no. Well, in the UK, there was a politician that was creating a digital human base on him, and he was to talk to all the voters, and then the artificial intelligence was collect what the voters want to do, and he was just going to do what the artificial intelligence decide. So we don't know. It's going. We are in the middle of something that is going to change everything. So let's see. Let's see. But it's better to understand technology and to manage artificial intelligence that don't understand anything related to that. So I don't know if we have any question from the internet. We have a question. He said, sorry, I have a software development startup. What do you recommend to protect and prevent an attack on user authentication? Well, user authentication is one of the barriers that we have for protecting systems or company, but it's not the only one. We used to say that you need to prevent attackers, and protecting the identity is prevent the attacker, because we are protecting user and customers on the identity. But you need to assume that at some point the attacker is going to get access to your system, so you need to create technologies to detect the attacker, detect the success of the attacker, and of course to later remove the success of the attacker inside your company. So one of the technologies that we were using is, of course, latches, but also which is to detect and the success of the attacker, which is wonderful. But also, as I was saying, in the case of identity, you need to manage strong mechanisms like passkeys, digital certificates, second factor authentication, etc. And if you are having a digital onboard, detecting deepfakes in the onboarding process, etc., with artificial intelligence. But it's not always one solution fits all. You need to think about what is your technology, what the attacker can be doing, and generate protection for all of them. So, any other questions? Go ahead.
So my question is about
Yeah. Yeah. Yeah, well, I'm going to repeat the question for the internet. The question is related to the how to tackle the problem of artificial intelligence or not artificial intelligence, because we saw in the past with Cambridge Analytic case that just with social network, machine learning, you were able to create a campaign to orchestrate the public opinion. And it's very complicated. The truth is that it's very complicated. So you can force the big social platform to put technological controls, which is something that we see today in Facebook or in Twitter or on many social networks in which they are forced to analyze the content and try to use machine learning technologies to say, okay, probably could be fake news or not. We are we are working hard on trying to detect when the text has been GenAI generated, when the pictures or the videos have been GenAI generated, have been manipulated. It's like the cat and mouse game in which we are increasing the capabilities of the algorithm to generate fake videos and fake pictures and the algorithms to detect them. But once that you detect that, you go and publish, okay, it's a fake, but it's like a war between who am I going to believe? I'm going to believe that it's true. I'm going to believe. So the proof of being a fake is also something that you believe because public opinion don't have the capabilities of trusting the proof of being fake. I remember when Cambridge Analytic happened it was worldwide because they were working in the UK, in Europe, in Spain, in the States, in a lot of elections. And I remember a conference after everything explodes of Barack Obama. He was saying it's bad because politicians before were discussing if something is good or bad for the people. But right now we are discussing about if it really is happening or not, because it's completely impossible to know what is happening in reality. Public media is very complicated. I really think that the best way is to teach people about having fact checkers internally, or to understand how information is controlled, and you can take better decision. But it's not easy. It's not an easy way. And I really believe that we are going to be suffering these fake news technologies today with GenAI, etc. And tomorrow we'll see what is the next piece of technology. So last question. Any last question? Sorry. Go, Javier. About GenAI. Well, it's it's not difficult to answer that. So if you are having all the data in Office, you need to use Copilot because it's the only one that has access to your data. If you are using everything in G Suite, probably you need to use Gemini to use that. In the services that we are creating internally in Telefonica, we are using different solutions because you need to think about the use case, and sometimes the use case is going to present information in front of the customer. So probably you need a large language model, but it's very expensive because tokens are expensive. Sometimes you are going to create a use case that is going to generate more efficiencies in your team. So you can use an SLM, which is not perfect, but is good enough. It's improving your performance and is not very costly. So you need to take the best decision in each use case. And the most important is that the barrier to deploy Gen AI in the companies is the data. If you don't have a good data strategy in your company, if you don't have normalized the data, you don't have very well secured your data, you have an issue. For instance, Copilot, if you deploy Copilot in your company and you don't have all the right security protection for the documents that you have in SharePoint and in OneDrive, anyone can ask to Copilot, okay, which companies is my company working right now? And it reads all the documents publicly available in the SharePoint, and it brings to you the right question that probably is not what the people of the company wanted at the beginning. So that's the answer. If you had the key question is, where do you have the data? If you have the data in Office, you need to use Office Gen AI. If you have that in G Suite, you need to use. It's the only answer. Data is the one that is leading this. So I'm going to finish here. So thank you to all of you that are connected on the internet. Thank you for being here. I hope that you enjoyed, and thank you for being here in person. Wonderful having you here. So thanks.